I will begin. What's that? I'll begin with a word of prayer. So, dear Heavenly Father, we thank you for this day. Again, I thank you for these students. Just help us to glorify you, what we do. Help us to understand a little bit more about math. And just pray that students would ask good questions as they have them, Lord. In your name I pray, Lord Jesus. Amen. All right, let me put this thing away here. Somebody emailed me a question. I think it was actually from the other section, but you know what? If they have that question, you guys probably have that question as well. Annoyingly, I've forgotten to get a staple for this. So there's 2 sheets to the attendance sheet. So if your name's not on the first sheet, it's on the second sheet, all right? We'll try to keep the sheets together. You just need to like initial in the first box is all right? I mean, if you're not here, don't initial, right? So, that should be easy enough to do if you're not here. Now, oh, rats. I just remembered something. So, at least one, I don't know, maybe one of you came to my office hours. I'm not sure who did. I know you came. I talked to you, right? But somebody else also came, and unfortunately, my student, I thought I was teaching the student this class up here, but I'm wrong. I'm teaching it down here. So I had office hours here before, but so I've shifted the office hours to 9:30 to 11:15, 9:30, 11:15 here, and I've also added a little half-hour thing here after 9 and 9 to 9:30 there. And then of course there's still the 2-hour blocks from noon to 2 Monday, Wednesday, Friday. So those are my office hours, okay? But you can email me anytime. Like you send me an email at 3 in the morning, it doesn't bother me. Like I'm either going to answer it or see it the next day, like whatever, right? But let's see here. So any questions about that? All right, let me put this away then. I did update the syllabus with the new office hours, I think. If I haven't yet, I will. And if you look at the website that's linked to the announcement, this schedule's there if you're ever looking for it, okay? All right. So, example 1. And let me just give you guys a warning about the mission homework before some of you might be working through the mission homework, right? Some of you are working through recommended homework. I'd recommend you do both. I don't collect the recommended homework, right? That's not graded. But mostly those are odd numbers. So you can check in the back of the book if your answer is right or wrong, right? And if you're curious about whether or not an even problem is correct or incorrect, I'm happy to, if you ask me about it in class, I'll work it out real quick and find out what the answer is, all right? That's totally fine. But what I was getting to is, in the mission, I have some problems on inequality and absolute value, right? I'm not talking about those this week. Those we'll cover next Monday, so don't fret, you didn't miss anything. This week we're focused on solving linear equations and graphing lines, all right? So the problems in the mission that are like that, there's like a few problems about inequalities and absolute value in the middle, but if you go past that, there's some 3 equations and 3 unknown problems that you'll be able to solve hopefully after Friday. You guys probably can solve them already. So, so here's one. 1/3 times x plus 2 plus 1/7 equals to, let's say, x minus 6. This might be worse than the problem that's in the homework, but it's something like that, right? There's fractions. How do we deal with fractions? So can you guys give me any advice here? What should I do? How do I handle this kind of thing? Yep.
Use the distributive property.
Use the distributive property is a good answer. We will first. You know what? Sure, I'll do it. let's see here. So that would be 1/3 x plus 2/3, right? Plus 1/7 equals to x minus 6. So where did I use the distributive property? Just where? Right, yeah, just here, right? These two terms came from that. Do you guys like fractions?
Oh, yeah.
No.
Oh.
So what you want to do is kill the fractions, right? No quarter for fractions. Oh, huh. It's kind of a fraction, isn't it? Anyway, in the sense of lodging troops, no quarter. So if you multiply this by 3, we'd get rid of the thirds, right? If we multiply by 7, we get rid of the 7th. We don't like the thirds or the 7th, so instead of multiplying by 3 or 7, multiply by 3 times 7, which is 21, right? Multiply the equation by 21, good things will happen. So I'm going to just go ahead and distribute through. So we'd have 21 times, x over 3 plus 21 times 2/3 plus 21 times 1/7 is equal to 21 times x minus 21 times 6. So we have to multiply 21 on both sides, and it has to hit everything, right? That's the distributive property. Again. Then what? Well, a lot of these fractions simplify, right? Like, this gives me what, 7x? What do I get here? 21 over 3 is 7. 7 times 2 is 14, so plus 14. And 21 over 7 is 3, right? Now, that 21 on the other side is what it is. 21 times 6 is 120 plus 6, so it's a minus 126. If you need to pick up a calculator to do that, that's fine. If you need to write it out with like the usual strategy for multiplying things, that's fine, whatever. However you figure that out, 126. Now what do I do? How about we bring all of the x's to one side and all of the numbers to the other side, right? So I think what I'm going to do this time is I'm going to bring all my x's to the right-hand side. I'm going to bring all my numbers to the left-hand side. So if I add 7x to both sides, I get like that, right? And what happened there? Why? What is, I don't even know. X. All right. And then I should add 126 to both sides, right? I'll add it here. I'll add it here. What happens after I do this? I get what? Why did I add 7?
That's what I was
Ay, ay, ay. See? Now I know you're paying attention. Very good. So now you're asking yourself, did he do that on purpose so the lecture was more engaging? Or was that actually a mistake? I don't know. It doesn't much matter. I've got nothing to prove here. So that is 0. When we add these, what do we get? 143. I like that. I'll allow it. The 126's, they be canceling. And 21 minus 7 is 14. Now, one more step. Or as I like to call it, the finishing blow. X is equal to 143 over 14. And there you go. Answer is good? I hope it's good. So there's an example with fractions. Let's work another example that's got fractions in it. Suppose I've got like 1/3 x plus 2y equals to 1/6. And I've got, I don't know, 1/10 x minus 1/20 y equals to 1 over 2. There we go. All kinds of fractions in this. Don't say I never gave you any fractions. I try to steer away from fractions in in-class examples, generally speaking, because you guys, the more fractions I do, the more you guys lose me, right? Because like whatever idea I'm talking about, you're more likely to understand it if I don't use fractions. So what's that? Oh, has everyone been accounted for? I probably should just call the name. Well, I won't do that. If you haven't signed the sheet, just come up after class and get to it, all right? So what should I do here? Well, here's what I would say. I would say treat each equation separately. Like first of all, don't try to solve it with the fractions still present. Take a second to get rid of the fractions. Clear them out by multiplying by an appropriate number. And you can multiply each equation by a different number because the first equation, if we multiply by 6, that's going to be good, right? The second equation, probably we should multiply by what? Yeah, 20. 20 would be good.
Or the least common denominator.
The least common multiple is what we want. That's right. Well, you're right, least common denominator, which happens to be, we don't disagree. You said least common denominator. I was going to say least common multiple of the denominators. This is the same thing. So multiply by 6. We have 6. 6 over 3 times x plus, what's 6 times 2? It's 12, right? 12y equals to, what's 6 times 1/6? It's 1, right? And if I multiply this by 20, we get, what's 20 over 10? I heard 2. What's 20 over 20? Well, that's just 1, right? What's 20 over 2? 20 over 2 is 10, all right? So I'll put in parentheses what I did over here. I multiplied by 6. I multiplied by 20, right? I probably should take credit off tests if you guys don't write in parentheses in words next to the step you make what you did, right? Like you should always write in parentheses next to what you did, what you did for full credit. It's something I'd never do because then I would fail everyone. But it would be nice for me grading, you know? I'm just kidding. Don't do that. It will slow you way, way down. But you see that maybe is the way we could make everything way more understandable. But if I do that, class will grind to a halt, and I'll get like 3 examples done in one lecture. So that's why I don't always do it. Anyway, so I'll stop threatening you. So 6 over 3. Oh, come on. What's wrong with me? That's a what? I think we can do that, 2, right? What should we do? How should we solve this now? Now that we've made it pretty, or purdy, depending on where you're from. How about we take these here equations and subtract them. If we subtract them, 2 x's are canceling. 12 plus 1 is 13y equals to 1 minus 10, otherwise known as minus 9. Yay, what's y equal to then? Y is equal to minus 9 over 13. Hooray, hooray, hooray. Now, am I done?
No.
No. What should I do next?
Find the x.
Find the x? And where should I do that?
The y.
Which one should we use? There's a right answer and a wrong answer. That's not really true. You could use either one, but the right one to use, because it's lazier, is the the second one, right?
Oh, so you go down, but you have to use the opposite.
Oh, in terms of the equation?
Yes.
That would be true if we were, well, sometimes with the substitution method, if you use the wrong equation, you'll end up with like 0 equals 0. But that won't happen to us here. Oh, you're saying is 9/13 becomes minus and minus gives you a plus, maybe? I don't. All right, I will stop trying to read minds. So that's 2x is equal to what? 2x is equal to 10, and the minus minus gives me a plus, right? But I have to move it to the other side, so I get minus 9/13. How many 13ths is 10? 130, right? So that actually gives me 121 over 13, which then gives me x is equal to 121 divided by 26. I'll get out of the way here. So I hope this is a good refresher of how to solve two equations and two unknowns. I'm going to let you guys work on them for yourselves now, right? I'm going to shift over at this point to talking about how to find equations for lines, how to work with them, that kind of thing. Unless there's a question. Do you have to use elimination to solve these problems? No. Could you use substitution? Sure. Does it matter to me which one you use? Not a bit. I will not force you to use elimination or substitution on the test. There's some homework problems that say use one method or the other. That's to try to get you to know both. It's not important to me that you know both. What's important to me is that you could solve that kind of problem correctly. All right? Is that fair? No. If you're like super confident about substitution, just stick with that if you're really good at it. All right? But also think about checking your answer when you're done. I say that, but that's not really very useful advice for this problem. Checking our answer here is like super annoying. But for a problem with nice answers, checking your answer is worth it. Because we all make mistakes. Some of them are not on purpose. So let's talk about lines. So I'll draw a picture. I'll start out with what you guys are most comfortable with. Y equals mx plus b. Right? What is that? Let me make it specific for my picture over here. What if I have y is equal to, I don't know, x, I'm going to put a minus x plus 2. Can you guys describe to me what that means? Yeah?
The first one above the top is slope-intercept form.
Slope-intercept form, that is correct.
And the bottom is point.
No, it's the same.
Point slope form.
Point slope. Oh no, we're not there yet. But that is. This is just so the top one's got variables in it. This is just kind of a generic template of the what'd you say slope-intercept. This is an example of a slope-intercept form. And what you can see, if we just look at these two, right? We just look at it and we can see, m equals to what? And b equals to what? I'll do the easy part. B is 2, right? And what's m? -1. Now m is equal to the slope. The slope is equal to the rise over the run. Does that even make sense? I don't know. What is rise and run? Like, we teach people this in math, so you accept it because you were told it before. But if you just went up to somebody on the street, it's like, the rise, the run. People would be like, what are you talking about? But we just accept that these words have meaning. But I think this is actually more meaningful. Change in y over change in x. These symbols just mean change. Here's a formula, y2 minus y1 over x2 minus x1. So if I had a pair of points on the line, I could calculate the slope by calculating the difference in y divided by the difference in x, and that would be the slope, right? Anyway, so let's graph this thing. So the y-intercept is 2, right? This b is the y-intercept. which means the y-axis, it goes through at 2. Right? And then what happens? It goes down. Let's see here. I should have set, I'm going to set my scale here. 1, 2, there, let me put it up a little bit. So here's my point there. This point is specifically 0, 2, right? So we go down 2 and over 1, so it goes here. Here's another point, right? This point here would be down 2 over 1, so that point would be 1, 0. There's 2 points on the line, right? And then it's a line, right? So I'll try to freehand it. I don't know. We'll see how it goes. So you guys know how to draw a line, right? See, I just don't. It's not. Man. Oh yeah. Wait, no, 0, 2, 0, 2.
No, from 0 to 0.
Oh yeah. What's wrong with me? I was just saying. I was thinking it was slope 2, or rather slope minus 2. Is it slope minus 2? No, I don't know where that idea came from. Sorry about that, but thank you. So what the gentleman in the front said is right. It should be 2, 0, and I should graph like what? Now that one was an actual mistake. So sorry about that. Let's see here. But we fixed it. Thank you. So there's my best attempt at drawing the line. And now is that a line? Not really. It's kind of wrinkly, right? But it's good enough, I hope. But there it is. This is the set y equals to minus x plus 2. In other words, any point I pick on this line, right, it's of this form. All right. So that was example 3. So just a generic comment. If your line looks like this, or you could have a line that looks like this, or you could have a line that looks like this, or you could have a line that looks like this. You guys tell me, what's the slope in each case? What can you tell me about m in each case? Is it positive? Is it negative? What can you tell me? So what do we got here? This is going to be positive, right? This is going to be negative, like the example 3 we just did. This one is undefined, or if you want to, give it a name, you could just say the slope is infinity. It's undefined, though, technically, right? How about this one?
0.
Yeah, 0 slope. So in some sense, like 1 over 0 is this one, This is actually, so if you think of infinity over 0, 1 over infinity as being 0, that kind of makes sense for these in some sense, because these are perpendicular lines, right? Sorry, I should have made the lines a different color than the axes here, but it's too late. I guess it's not too late. I think I've just ruined this red marker. Oh well, anyway. Okay, so standard example. I'll put it up here, and I'll let you guys see if you can figure it out. Let's see here, example 4. Find equation of line through, let's say, -2, 3, and 8, 10. So let you guys work on that while I'm fixing my camera. You got about 15 seconds. So what would you advise as a course of action here? What should we do? Find the slope. I like that. That's a really good first thing to do. Can you guys tell me what the slope is? Anybody figured it out yet? What's that? 7/10? We'll find out soon, right? So let's see here. Change in y over change in x. So I'm going to do 10 minus 3 divided by 8 minus a -2.
Oh.
Uh-huh. Which,
y2 minus x2.
yes, well, y2 minus y1 and x2 minus x1. But yeah. So 7. 7/10, right? Now, then what? Now, if we knew what Michael was telling me about, Michael, right? If we knew what Michael was talking about, we could finish this problem immediately. What he was telling me about is so-called point slope form. Point slope is this. It says that line through x1, y1 with slope m has equation y is equal to y1 plus m times x minus x1. So I allow you guys a page of notes on test 1. Now you have to make it. You have to bring it. I don't provide it for you. Like some of you will take physics with Dr. Dinsmore. You know what I'm talking about? Oh, I think this, of course, is a prerequisite for that. So how would you know about it, right? But some of you will end up there, Physics 201. And in there, he actually provides you this formula sheet with like formulas you have to learn. I'm not nice like that. I make you make your own formula sheet, all right? But, you know, you still need to know how to use them, right? Like having the formula and applying the formula are two different things. But this is a mighty fine formula to have, this one right here. Because with this formula, I can write down the answer now. The answer is y is equal to, I'm going to use this for my y1, x1, right? This one right here. So y1 is 3 plus 7/10, parentheses, x minus a -2. Of course, what is minus a -2? What is the answer here actually? 3 plus 7/10, x plus 2. Now you might say, well, my high school algebra teacher would have taken off points if I left it like that. Show of hands, who would have gotten points taken off if it was left like that? That's right. So, but this is really the answer in here. You don't have to multiply it out. That is a perfectly good answer. I like this answer more than what you're about to do in the following sense. I can look at this equation and I can immediately tell you this is a line with slope 7/10, and one of the points on the line is in fact -2, 3. I can't do that. I can't do that with the slope-intercept form, right? Now, the flip side of it, of course, is if my equation looks like this, I also can't tell you what the y-intercept is by inspection. I'd have to work to figure that out, right? This is a perfectly good answer, though. unless what? Unless I explicitly have the instructions which say, please leave your answer in slope-intercept form, in which case I would like you to multiply it out. All right, but if I don't have that instruction, you don't have to. Example 5. So let me try to show you what I'm talking about here. If I tell you y is equal to 11 plus 3 times x minus 17, and then I ask you to describe the line, can you do it? What can we say from this formula? What does this formula tell me? This formula tells me what? Line with slope m equals to, I heard the 3, very good, and goes through the point what? See this? 17, comma 11. A big part of algebra, besides the manipulation of equations, is just identifying an equation for its meaning, right? Understanding what the coefficients mean in its interpretation. That's what I'm trying to teach you with this example. All right, what other thing do we like to think about with lines? Did you guys know? I guess I could have talked about what this example meant, but I seem to have erased it. Wait a minute, we still have that though. We still have that. So let's focus on the purple version. The Garrett equations. Does that joke land in here? No? I've been teaching my children stereotypes this summer. Lots of stereotypes. They're very into rage now. Still no clue what I'm talking about. No? Tall guy, bearded guy, purple hoser, something. Okay. So I have seen, I think, the entire catalog of, careful, there's water on the floor there. My daughter is super bummed today because I forget which class she's in. She's a freshman here. And she set her backpack down, and then somebody had coffee on the floor. And now all of her books are caffeinated on the bottom. It's really annoying. But anyway, I'm talking about Dude Perfect, right? The second most popular, stupid, waste of time YouTube channel. Not enough math in that show. But I think I've seen all the episodes several times this summer. It's all the kids watch just over and over and over again. And I've grown to love the Rage Monster. But anyway, if you don't know what I'm talking about, good for you. So can you tell me what each one of these would be? What these would be each one of those would be a line, geometrically, right? So can you tell me how to graph, how to view 2x plus 12 y equals to 1 and 2x minus y equals to 10. How do we view these graphically? So here's where, if you'd done substitution, that would have been nice, right? Although the second equation is easy, right? You solve for y. You can kind of see it immediately, right? Here, we get y is equal to 2x minus 10. So, okay, well we got that, right? That means what? You need at least two tools to take care of line problems, right? You need the slope-intercept form and you need the point-slope form. You need both of these for best results. What's that?
The y-intercept is -10.
Okay.
The slope is 2 over 1.
Yeah, so slope is 2, so it's here-ish. All right, I'm not content with my previous line, so. I knew this was here for something. So, are we going to get back to using that again? Are we playing that game again? Is that what we're doing? I don't watch the news, but I've heard rumors. They're trying to bring back the magic. Oh, wouldn't that be exciting? Let's see here. I wish your generation would just revolt if they try it again. Don't tell John MacArthur. All right, so sorry, there's too much inside baseball for you guys. Y equals 2x minus 10. And that's the purple line. Great. Then what? How about this one? What do I do? Y equals what? Oh man, I seem to have... I really need a smaller ruler. It's not optimal. Solve that for y. What do you get? Y equals 2? 1 minus 2x divided by 12. Let me write that again down here. So y equals to 1/12, right? Minus 1/6 x, if I simplify things here, right? Because 2 over 12 is 1/6. So you see that the first equation actually corresponds to a line with what? With y-intercept 1/12, which is like here-ish. And slope is minus 1/6. So that's like, it goes 1 down and 6 over. So let's see here, 1, 2, 3, 4, 5, 6-ish, something like that. I think I need to go get my ruler again. Just a second here. Probably should get an assistant for this. Stay, don't you move. Get. Well, I tried, guys. I tried. It was close. I really just need to take that plastic thing and just keep the wood there. So anyway, roughly like that, right? And see what happens. So each equation gives you a line, right? There's an infinity of points which satisfy that relation between x and y, both of them, the purple one and the black one. But there's just one place, right? There's just one place where both equations are true. Right here, right? That's what this means. This point is 121 over 26, comma, minus 9 over 13. That's kind of ugly, right? I mean, I think if you tried to find the point of intersection with graph paper, that would be pretty tough, wouldn't it? But with algebra, we found it without too much trouble, right? Any questions about this? Does this make sense? Anytime we're solving a pair of equations, a pair of linear equations, geometrically what we're doing is we're asking the question, do two lines intersect? And what happens? Do two lines intersect? Usually they do, right? Except when, what? They're parallel, right? If two lines are parallel, there's no intersection point, right? So if you look for the common point of two parallel lines, you have no solution, right? What's the other possibility? You could just have both of the lines be the same line, right? And then every point on the line is a solution. So you either have a unique solution like that, no solutions at all, or infinitely many solutions. That's the same phenomena we saw with one equation, one unknown last class. That situation continues to be true actually for 3 equations and 3 unknowns. It's always the story. If we're working over the real numbers, we either have a unique solution, no solution at all, or infinitely many solutions. Them's your choices. All right. What else can we talk about with lines? Any ideas? So that was example 6 that we just did. Did I move the camera over here? I don't think I did I? So what we're going to talk about next is parallel and perpendicular. When are two lines parallel? They have, I heard they have the same slope. Yep. When would they be perpendicular? Yep.
When they have the opposite slope.
What do you mean by opposite?
When one slope of one line is the opposite of the slope of another line.
But what is opposite?
In a way that it makes like, I don't know, like the faces are going exactly opposite of the lines.
So you're just talking about the geometry of it? That's fine. So that would be like parallel up to my my artistry. Perpendicular would be more like this, right? That's what you mean by opposite. So if this one has slope m1, this one has slope m2. If this one has slope m1, this one has slope m2. What's the relation? Well, that's easy enough. m1 equals m2, right? Over here, m1 is equal to minus 1 over m2. It's the negative reciprocal. That's what gives you perpendicular. Also, special case, vertical lines, horizontal lines are perpendicular, right? There we'd have to introduce arithmetic of infinity if we wanted to extend the formula meaningfully. But if I did that, then you might tell the other math professors and I might get in trouble, so it'll be a secret between us. But example 8, here it is. Want equation of line which is parallel to y equals to 3x minus 2 and has y-intercept of 7. All right, that's an example. You guys think about it, see if you can write down the formula for that. Another example would be example 9. Want line perpendicular to y equals to, let's say, minus 2x plus 7 through the point 8, 9. We'd like to find the equation in both cases. So can you guys tell me what was the answer to problem 8? Y equals to what? 3x plus 7. Does everyone agree with that? Does it have a y-intercept of 7? Sure does. Does it have the same slope as y equals 3x minus 2? Yep. There you go. So, you know, if I put that question on the test, don't miss it, right? That's a gift. You should be like, please, sir, may I have another, right? I mean, it's good. It's nice. How about this one? I'm given a point, right? So I should use point slope. And here, that would be 9 plus m times x minus 8. Now what m do I want here? I want the negative reciprocal of the slope of the line I'm trying to be perpendicular to, right? So since my given slope is minus 2, this needs to be, what's minus 1 over minus 2 is equal to what? 1/2, right? So the answer here would be 9 plus 1/2 times x minus 8. And unlike your high school algebra teacher, I'm chill with this answer. So you can leave it just like that. It's copacetic. It's all good. There's one final thing for me to tell you guys about lines. It'll be done for today, which is one of the uses of perpendicular. Yep.
On example 9, how did you get from the -2 to the 1/2?
So the given slope, let's call it m2, was equal to minus 2. And then the perpendicular line has slope m1 equal to minus 1 over m2. which is minus 1 over minus 2. The minuses cancel, and I get 1/2. Did I perceive your question correctly?
So you just, so it would have been -2 over 1 instead of -1 over -2?
Yes, -1 over -2. Here's a good check on your work. If you're trying to find perpendicular lines, if you take the product of the slopes, right? If you have two lines, you take the product of their slopes, it must be negative. If it's not negative, you did it wrong. Because one should be positive, the other's negative, the one's negative, the other's positive. Like they have to come in a polar opposite pair. Unless, of course, we're in the vertical horizontal case. So the last thing to tell you is if I had a line, I don't know, like this. Say it goes through the point 1, and we say, I don't know, y equals to x plus 1, all right? And I want to find the point on this line, which is closest to, say, this point over here. I don't know what that is, 5, 2. So my question is, which point on the given line is closest to the point 5, 2? Well, this is a great place to apply the concept of a perpendicular line, right? Because the perpendicular line should give you, how do we define distance from a point to a line anyway? It's by definition the distance to the closest point, right? So like, what you do is you take the perpendicular line here. This point is the closest point. Closest point. This marker is near death. I'm just going to put it out of it. If I try to, I usually throw markers into the trash can, but if I do that, I'm going to hit I'm going to hit you. It's okay. I'll just, you live on a little bit longer, sir. All right, so you just have to find the equation of this line and then look for that point of intersection that finds the closest point. What's the equation of the red line? Simple. It's y equals 2 minus x minus 5. There's some parentheses here. Why minus? Because the slope of the black line is 1, which means that negative 1 over 1 is minus 1. So the slope of the reciprocal line is minus 1. So that would be the equation of that line, and you'd look for where this is equal to that. That would give you the point of intersection. You could find the closest point. That's how to solve that problem, okay? But anyway, yep.
Does the S represent in the parentheses?
Oh, that's a 5. Sorry. This is a totally legitimate question, and it has been asked many a time in my classes. I never learned to write a good 5 versus S. Thanks, guys.